Hi everyone, in this tutorial we'll talk about the simulation of random walk of large number of particles. In the previous tutorial we talked about the simulation using Excel sheet of one particle, and here I will show you how to simulate the random walk for large number of particles. So let's define the particles first. So let's say I have particles particle 1, and then I have particle like this, like suppose I have 100 particles like this, and then define the position. So let's define time is equal to 0, and position x and y are both 0. So all of the particles starts at origin, and so now this is our x and y. Now to define the movement, let's say time is equal to 1, and now because it's moving in the random direction, so we have to define a random variable. So let's assume that we want it to move in any direction, so and it should take a step either positive direction or negative direction. So how do we uh, simulate that random step? So for that we need a random number, and as I told you in my previous tutorial also, so random number in Excel is equal to rand and parenthesis. So this will give you a number between, so you can double click and say enter again, so you can see it give you a number between 0 and 1. And if you have to define a number between 0 and 2, you multiply this number by 2, and this will give you a number from 0 to 2. And if you have to define a number between -1 and 1, you subtract this number from 1. So how does it work is like, so it give you a random number between 0 to 2, and if you subtract it from 1, then it will give you -1 to 1. So suppose if I get a number less than um, 0.5, because from rand from rand I can get mine less than 0.5. So if I multiply by 2, it will be less than 1, and then if I subtract it from 1, it will be greater than 0, and if same way I can get less than 0. So you can think about it, and it's not that tough. So now we defined this number, and same way we can define this number again, and you can see I have two numbers. And then what I can do is I can take this step and add the initial step into it. So I say initial step plus this step. So this is not difficult, and you can say enter, and similarly I can drag it here, and you can see, so for y also I added a random number. So this is your movement at time 1, and you can uh, drag that again into the 100 particles, and you can see, so this is your position at time 1. Now what I'll do is I'll copy the same thing and paste it here. So what will happen, because this is a beauty of Excel sheet, that now because I copied it and I didn't put any dollar signs on the numbers, I can see, you can, if I double click on this and check the formula, so what it does, it automatically move the cell from B4 to E4. So now you can see that now I'm adding a random step to the position which was there at time is equal to 1. Now you can see that, so my position, uh, so this is my position at time 1, and this is position 2, and I can do the same thing again and again, so as many times I want. So I say V, and then, so let me, I'm not updating the time again and again, so let's delete the time and then do it again and again. So you can see, you can see this, that I can generate the walk like this. So actually if you use VBA, then you can do this automatically, you don't even have to paste this, but this is more of a conceptual programming. I wanted to show you the concepts, and that's why I'm doing it this way, because this make it much easier to understand. Otherwise you can just update the same cell again and again. You can see my simulations some of the simulations I've shown, that it's not a tutorial but just a demonstration on how you can generate the movement of the particle. There is a nice animation on the another YouTube video, but here I'm just showing you the concept. So now you can see. So let's see, if I plot this points, say insert and say points, so you can see all of the points. So all of the points are at 0. So you can see all of the points are here at 0. Now if I plot these points, you can see that they have moved with time. So you can see that they have diffused away, right? And now if I plot these points, so you can see they are much more scattered now. And now if I plot these points, so they are much more scattered. And because right now the scale is not defined, so that's why you don't see the difference. So I can define the scale, and then you will see the difference. So let's do that. So what I can do is select this scale and say format axis, and say fixed -10 and maximum 10, and same way for this axis, and say format axis fixed -10 to 10, and say close, right? And then let's delete this point, and let's take this point and say format axis fixed -10 and +10. You can see, oh, this one is format axis fixed -10 and 10, and now you will see the difference. So I can, let me make them same shape. Fixed 10 -10. This is already 10, but I want to fix it. So now you can see the, so what I'll do is I'll double click on any cell and say enter. So you can see that at t is equal to 0, the particles were all at one place at 0, and then they diffuse away from the center, and with the time their movement from the center, or their distance from the center, increases, but it does not increase uniform, like the particles are not moving only farther away, they are moving in the random direction, but by probability some of the particle reaches farther away from origin as compared to the others. So this is just a demonstration of the concept. And if you know VBA, I have also provided a tutorial on how to use VBA. So in that case you can really use the animations, so you can animate this movement of particles, and the particles will move in the random direction. So so this is the conceptual work, and I hope this will help you understand the concept which is behind simulating the random walk. So I hope this tutorial will help, and if you have any questions, please comment on the YouTube, and if you like the video, please do give us your feedback.